Okay, I'm going to walk through another section of the mini MUDOC challenge. Basically, what I thought I'd do is work with the Kaggle house price questions and pretend that these novice division questions were asked of the Kaggle house price data. I'll share this notebook with you also here. Um, so here's our notebook. The first thing we have to do is import these files here. So I'm just going to hit import, grab. I'm going to do a CSV because, again, that's what I'm used to, but we'll look at that in a sec. So upload that. Okay, then why isn't that showing up here? Yep. So yeah, that should show up here. Oh, I think it's still loading up. And then we're importing all of the libraries that we need. I just like to do all the imports at the beginning because they're so slow. Then I have different sections here. So the first one is to, understand and analyze the response variable distributions. So the response variables are these two: the match length, which is a number, in the closure region, which is a categorical label. So again, we'll look at the same thing. How do we look at a numeric feature and a categorical feature to start with? So here we're, let's see, we're importing this data. Again, oops, it didn't get actually imported, looks like. Let's try that again. Okay. Okay, I had to restart my notebook here again and import these again. I think it's because I had them imported earlier. So I've imported my libraries. I'm going to read this. And again, I've commented out the line to read in the Excel file. If you're doing Excel, you can do that. Then we're going to display information. We're just going to read this into a data frame. I'm just calling it my data frame here. So that would be my data frame that I'll be using for this data. We're going to show information on it again. And this is just going to be looking at understand and analyze the response variable distributions. So first, I guess before we look at those, we're going to look at all the variables here. Some things to note is that a lot of these have a bunch of non-null ones. Some of them have a bunch of null ones and only 90 like non-null here and stuff. Again, you can kind of look through your data and see how kind of noisy the data is. Like fireplace quality, only about half the records seem to have a non-null value for that. Here, some of these pool, only 7 houses apparently have a pool, so the rest are null for that. So, okay. I can also ask it to describe the data frame, and this will show the count, the mean, the standard deviation min and max, and then the the 50% and stuff like that of it for each of this. So here's a lot frontage. There's 1,210 of them. The mean is 70. The standard deviation is 24, and they go from 21 to 313. So you can just kind of see that year built. Again, they're showing these numbers, but again, everyone has a year built. So there's 1,460 of them. The average is 1970, and they go from 1872 to 2010 in this example. Again, sometimes that's useful just to see the data, and then you can use again head, and here's all the columns in this data. So you can do something similar, just so you know what just to kind of see. Now we're going to look at the important features. Again, I'm going to pick 2. I'm going to look at the sales price, which is what we have to pick or predict with the numeric field. I'm also going to look at the sales type, which is a categorical field here. So now we can do the same thing. We can ask it to describe the sales price. Now that actually is up here. If I were to scroll over all the way, I would see that. But sometimes it's nice just to say, just describe the sales price and get information about that. We can also then plot the sales price distribution, kind of see how it lays out. We can do a violin plot of the same thing. So we can see there's a number of houses above $500,000, but a lot of them are down in here between 100 and 200,000. Very old data at this location. So nice to see houses that you can get under $200,000. That's cool. Okay. The other one, sales type, is categorical. So again, we can describe it here. We don't see as much numbers, but we do see 9 unique values. We can count them and show, again, most of them are, I don't know what a WD sale is, but most of them are that. There's a couple new sales, some COD sales, and some of these other ones here. So again, most of them are just this one type, but you can look at that. And then you can also plot this out the same way here. And again, maybe when you're doing this, some of these you might want to just eliminate here if there's not enough data to make this useful. Maybe we would just want to get rid of those and not worry about those. You'd have to decide. And again, here's another chart showing the same data as a pie chart here. So that is just kind of understand and analyze these two variables here. Now we're going to look at these variables related to some other type. Here they're asking about the program type. So I'm going to look at the same thing. What did I choose? I decided to look at roof style. I really like the different styles of roofs on houses here. So, and I think that's important. So we're going to look at roof style. So again, I just like to explore the roof style. It probably wasn't a great variable to grab because most of them are gable. There are some hip here and a couple, flat and stuff, but it's really highly biased to the gable, traditional, peaked roof here. But again, we can show that. We can also show kind of, then we can look at the sales price by the roof style here. And again, I don't see a lot of trends here. I would have thought like flat roofs would in general be more expensive here, or hip roofs. I'd say maybe hip roofs again, but these all look like, they're kind of blobbed in the same area. I don't see one way up here and one way down here. Here. So and there's another graph of the same thing here. So again, that's looking at comparing this categorical value, the roof style, to this numeric value, the sales price. You can do something similar with two categorical stuff. Now we're looking at the roof style versus the sales type. We can do this sort of graph here called a crosstab. And so we can see, like, for a flat roof, what kind of sales. And so all the sales were these WD sales here. We can look at like a hip roof. The hip roofs have a surprising number of COD sales for how many the ones they are for that. So again, we can look at some of this data here. And again, we can also just plot that out and see where some of the graphs are. Again, this isn't all that interesting data. Maybe I shouldn't have chosen rough type, but I did. But you can use this to analyze anything else. Now I'm going to close up these as I do. I think this is section 3. Close up section 2. And close up section 1 here so I don't. Okay. Okay, section 1, 2, 3. So section 4, we're going to look at does this distribution vary over time? And again, you might think of this as a time series analysis, but this really isn't. We're not predicting it based on time alone. That would be a time series. We're just saying, how does it change over time? Again, we're going to look at sales price and sales type over time here. So I think we can just break it down and look. I'm using the date sold as my variable. Actually, it's the year sold here. I'm just using that. And again, sometimes you might have to do some conversion to convert that into a date time value. And then we can plot it out here. You can actually plot out and tell it how many bins to put it in. So it'll break this date up into so many bins. And I could change this to like 10 bins. So it's not there. That's the size of the graph here. Well, right now it is on 10 bins, but let's say we only want it in 5 bins. We could change it to 5 bins here. It'll generate this with only 5 bins for this. Or you could do 30 bins, whatever here. So it'll create a histogram and you can set the number of bins for this. So again, it's just showing the date sold and well, this is showing based on date sold how it spreads out. I'm somehow missing the labels down here, but that's it. We can also look at the sales year, so I can just grab the sales year. Actually, but on data within date time, you can maybe just grab the sales year by just grabbing the year from a date here, and then you can look at like here is every year what is our distribution of sales prices? And do we see these going up or down as the years go by? And in here, from 2006 to 2007, I don't see a whole lot of change in sales price. I would have thought this would be going up, but during this part, the sales price stayed pretty flat here. So the sales year does not really seem to have any impact on the sales price in this example here with this stuff. Again, you can look and I mean, you don't have to do violin plots. I like violin plots, but you can work with AI and do anything. But again, we're looking at two things: this year is numeric and the sales price, or actually the year is is actually kind of categorical in this time. You also look at here's the plot of the average price with the measure of the standard deviation on each side, and again, we can see it's actually going down a little bit over time for that. So. We can also look at our year sold and our sales type and a breakdown of that. And again, we're doing a crosstab and then plotting this out. So you can see every year how this, and this look like we had a lot more of new sales in 2006 and 2007 than we did in 2010 here. So you can see some variation with that. Also starting in 2008. I think 2008 was a big economic crash. Actually, like 2007 was a big economic crash, right? You don't remember that. But again, COD is where you can't get a mortgage and it's financed by an owner. And so we're seeing people just trying to sell these houses or buy these houses any way they can at this point for this. So, okay. The last thing is trying to determine which variables have influence on these variables here. And again, they look at, there's the big little demographic variables, and then there's also these other alignment variables. They're still looking for the influence. I'm just kind of grouping those together in how do we see if a variable has an influence on it. I'm going to focus, well, let's just look at this. First, I'm going to separate the numeric from the categorical, columns or features. So I'm just going to grab all the numeric ones and grab all the numeric ones. And I have a data frame for numeric and a data frame for categorical here. And once we have numeric, we can just do correlational stuff. And again, correlation works well with numbers. So I'm going to try to look at the numeric thing, which in my case is the sales price. So I'm going to look at all these numeric values and how they correlate to the sales price. Remember, correlations go from -1 to 1. 0 means there's no correlation or no relationship between the two. 1 means if you know one, you can predict the other one. -1 means if you know one, you can predict the other one. It's just the opposite sign there. So again, if you know the sales price, that's directly correlated with the sales price. That's always 1. But your overall quality is 0.8. I don't know what this living area, garage cars is here, garage area, basement square feet, first floor square feet. A lot of these are pretty highly correlated with the sales price. So these would all be important values to use or features to use when trying to predict this. Now we have to watch because some of these are going to be correlated with each other. Like the basement square feet and the first floor square feet are often, the house often has the same footprint on the basement as the first level. And so those two are often same. Same with the cars, like a 3-car garage is going to have a bigger area. So often if you know like the car area, you can predict what size, if that's a 2 or 3 car garage or something like that. So we've got to watch. Some of these are correlated with each other. So we can show this sort of map. It's hard with this many features. This is a heat map of the correlations, but this is showing. Let's see if I can look at here. So here's the garage area here. And again, here's the garage type. And so certainly along the diagonal, we're going to see a lot of that one. But here, there's a 0.8 correlation between the garage area and the cars in the garage. So if you know one, you can predict with quite accurately the other one here. So again, we want to watch those and sometimes take it, maybe not include both features or just be aware of that here. We can also, here we're doing the same thing. We're calculating same correlations with the sales price. We're just selecting the 10 top features. We're doing absolute values here. So we're combining both I forgot to mention the negative ones down here. But they weren't that high, negative 0.13 isn't all that high. So if you saw negative 0.8 or something like that, then that would be an important feature here. But here we're doing absolute value to get rid of that, and we're just plotting. Here's the 10 features that correlate most with the sales price here. So overall quality of the house, the living area, the garage, how big the garage is, the area of the garage, total basement, first floor, square feet size, number of full baths, stuff like that, and year built. So those are your primary things. Now you can do this. There's ways of looking at this variant, or this how eliminating or features that are linear or correlated together for this. And this is just one. You can look up this or other ones here. So we're trying to look at this ones that are not collinear or not dependent on each other. Another way of saying this is we want features that are orthogonal, so kind of opposed from each other. So if you know they're independent, so if you know one, you can't predict the other. So this is just a way of looking doing independent features. I don't think you really need this, but again, it's a common something you can consider at some point here. Now, once we know this, these are numbers, predicting numbers. We can just do simple linear regression, create a model, and this is actually, I think this is actually down here. I thought there was one to create a model for this, but I'm not saying. Oh, create a model for the match length. So again, here we're just using simple linear regression. We have our numeric fields. We're taking out the sales price. We're taking the sales price and putting it in our X. So we have our input X and our output we're trying to predict as Y as a sales price. We're breaking up into training and test data. We're creating a linear regression model, fitting the data to that. Then we're predicting the test data and we're measuring this. We want the R squared to be high, so it's 0.8. Not bad. No, I think we want that low. Sorry, we want the error to be low. So 0.8 is kind of high there. So this is simple linear regression. Something like decision trees might be better. And decision trees, while I'm showing it here, will let you figure out how important different features are in creating the decision tree. So here we're doing the same thing, but now we're creating a decision tree. Now, the standard decision tree is a categorical model, but there's a decision tree regressor that will do regression with the decision trees, and that's what we're doing here for this. And again, we're predicting. And here the error is a little less, so it's probably a little better, I would say. But again, I'm not actually too concerned about this right now here. But what we want to do is once we have this decision tree model, we can get the feature importance values out of it. Oops. Sorry, I edited this wrong. Just clicking in here. Okay. Okay. You can take your model, any sort of tree or boost based model will have feature importance. We can grab that, grab the feature stuff, and look at this. And so this will show which features are most important here. And again, the most important feature is the overall quality, the living area, second floor living area, total basement square foot, lot size. So it's showing which, again, very similar. It should be very similar to these values here of what are most important. So just another way of getting at these. I like this way because it actually shows what a trained model will use to predict these values here. And again, we can graph this out and show which features are the most important. It tends to exaggerate the most important features because decision trees tend to use that one feature initially a lot and then use the next feature. So I wouldn't worry so much about the fact that this was so much higher than this. I would worry more about the order of these. So now you can do the same thing for categorical features. So again, we're looking at we're trying to predict, let's say, the roof. We'll use the roof type or something like that or any of the categorical features to predict the sales type. So sales type is a categorical feature here. Now, standard stats will tell you to use ANOVA measurement for this. And that's from stats class. Hopefully you've had a stats class and you can remember ANOVA. It's a really common thing in stats class to not look it up. Almost anyone judging you will be familiar with ANOVA and be kind of expecting you to talk about that and P-scores and stuff like that. So you can certainly apply, and you can do that all in here too, but I don't like ANOVA. I never have. I've kind of blocked that out of my memory from stats class, so I'm not going to go over that. But again, it's probably an important model for this because stats people love it. Instead, we're going to do the same thing, do importance measure for a tree model. Now, in order to do a tree model here, we can either do one-hot encodings of the data, categorical data. So we create one-hot encodings, also called dummy variables for each one. Or we can use a special model called CAT, categorical boosting. It's a special model designed implicit or internally for categorical models. So let's do, so here's our categorical features. Here's all of our categorical features. We're going to clean them up a little bit. I'm just removing anyone that's empty, I'm replacing with the word missing there. So and converting everything to string types here. You could also look at removing, irrelevant categories and grouping similar categories or stuff like that. And I'm not doing any of that here. But here. Now, once we have that, we're going to do one-hot encodings. Now, one-hot encodings generate a whole bunch of new features, one-hot encoding or dummy variables. So I'm only going to do it for right here, lot, configuration, and neighborhood. And again, we're trying to predict the sales price. So we do our one-hot encodings on those. We then do this. We're going to do our tree regressor to predict that. I wonder if we could have done just a decision tree, not a regressor here. I don't know. But we're going to predict here. And here's our result. That error is getting a little lower. Here. And once we have that, we can extract the importance features. Now, this isn't going to tell us necessarily that if lot config or neighborhood is better, but we did one-hot encoding. I should have printed off the encodings here. I should have done that. But now there's an encoding for each neighborhood type. So like neighborhood North Ridge Heights or neighborhood North Ridge or Stonebridge or each College Central or each of these neighborhoods has their own their own feature with one-hot encoding. And same with, are you on a cul-de-sac or are you something else? So each lot config has its own one. But now we can look at the feature importance of all these, and we can see like these are the most probably important. If you know you're in any of these neighborhoods, you can predict the sales price pretty well. Same with certain lot configurations. If you live on a cul-de-sac, you can probably predict you have a high house price or a corner lot here. So you can kind of look at that. Now, if you want to and then we can plot that all out here, of course, too. Now, if you want to look at all the, how the full categories work, we can use this categorical boosting we need to actually install that here, and then we create our model the same way. So again, we're doing all of our categorical data. We're predicting the sales price here. Oh yeah, that's why I'm using regression, because I'm still predicting the sales price, not the sales type here. And we're doing that. This takes a while to run. This is a complex boosting algorithm for this, but we're training it and fitting it, and then we predict it here. And then we can get again, the feature importance here. So like basement finish type and basement exposure, exterior quality, garage finish, those sorts of features. Oh, actually, I should have scrolled up. So actually, it shows the number values here of the most important features, and then we can graph those. So basement quality here, kitchen quality, neighborhood quality. These are the most important features in our model for this. So hopefully that helps, and hopefully you can do something similar with your data if you're interested.